to power precision medicine with Federated Learning. And then for those who are here with us, we will have a cocktail. We can stay here at dataiku until 10 p.m. So about us. So Pyladies is an international community. We focus on Python and tech-related stuff. We especially try to encourage women to join tech, but also we welcome friends. So you're happy you are with us. And here so there are lots of chapters all around the world of Pyladies. Here in Paris, it's run by 3 volunteers. It's me and Maud, which you probably know, and we now welcome also Mojde, who joined us last month. So we are very happy to have her in the team as well. So we always ask you to be respectful and kind to each other. If you want to look at our code of conduct, you can find it on the Pyladies page. If there are any issues, you just don't hesitate to contact us either by email or just come to one of us and we'll try to deal with that. So this event is being broadcasted live, and we also welcome on-site and online interactions. So don't hesitate to ask any questions to our speakers. And also we are very happy to have the possibility to be networking on-site. And as we do it as volunteers, we are always very happy to hear your feedback. So if there are any things you would like to tell us, please contact us, tell us if it was good, or if there are any things you would like us to improve, maybe next time we can try to be better. So how to contact us? There are just 3 ways. Slack, you can join us on Slack of Pyladies and then find our City Paris chapter. You can also find us on Twitter. And of course, for those who are joining us online, you already know that we have also the YouTube account. We are always searching for speakers. So if you have anything you would like to talk about and you think it's interesting, please don't hesitate to tell us. We are also looking for venues. So thank you for dataiku for hosting us this time, but perhaps your company would like to host us next time, so let us know. And we are always looking for sponsorship of stuff like goodies. And speaking of goodies, we have some stickers for you tonight. So I will distribute them afterwards. So a little advertisement, EuroSciPy. I don't know if you know, this conference is scientific Python. It has not been going on for 2 years, I think. And finally, it's on site again in the end of August. I think it's in Switzerland, yes. And there is a call for proposals until the end of May. So if you are interested, don't hesitate to apply. And now I will give a hand to Alexandre from dataiku.
Thank you, Maria, for the introduction. So my name is Alexandre Abraham, and I'm research scientist at dataiku. This is the mandatory introduction to the company, the product, and what we do. But feel free, I tell you already, if you have more questions, to visit Varun, who has a much more deeper knowledge than me. So for those who don't know, dataiku is a company that provides a data science platform that aimed at getting all the roles around data science together. So the infra people, analysts, data scientists, everybody working together on a single platform, bringing their expertise. And we help companies setting up their projects, from the installation of the platform, helping them setting up their ML models, and everything until production. So that's what we do. And today we host Pyladies because we have our platform is tightly linked to Python. We rely on it a lot. You can also code in Python in it, import your custom models, do a lot of things in Python. And we also therefore participate to the Python community. So we'll do now some personal advertisement. So I'm in the research team, and we are working on active learning, domain adaptation. You have other people in the back working on uncertainty, transfer learning. We have a research project around that, and we are looking for collaboration. So if you are working on that, do not hesitate to speak to me or to any of the dataiku people here. And that's it for me. So I guess I will hand out the mic to who is presenting first. I don't know.
It's going to be Jean.
Jean starts.
No.
No? Okay. No, I'll let you do the organization.
Yes, you're right. So Merve, if you want to continue. So I'll just take a second because we're going to switch laptop.
I'm sorry.
No problem. Happens all the time.
Can I? Okay. So I can. We will share. Okay, I do not have the slide. So problem is, so I have to share like all of my screen for the StreamYard. Is it okay?
Yes,
Okay.
it's okay.
So I can just do this, and then you can just get me. Can you check if it is?
Yes, it's okay.
In StreamYard, do you see? Okay, cool. Hello, I'm Merve. I am working at Hugging Face, and I'm going to talk about how to build machine learning demos without actually knowing front end and other stuff today. So about me, I am currently working at Hugging Face, and previously I was a machine learning engineer working on predictive analytics and natural language processing. You know, like in those startups, you are like a one-man army working on multiple things. That was me. And I also am doing my master's in data science, and I'm also taking part in communities. I'm a Google developer expert in machine learning and community builder at AWS. And yeah, like I do multiple stuff. But today I'm going to talk about building demos. So you might have heard about Hugging Face with the library Transformers because that's the most popular thing. So what Transformers does is that there is this new paradigm called transfer learning in which you can just transfer the information from one model to another. You might have heard GPT-2, BERT, or let's say even VGG is considered to be transfer learning. But this is not the only thing that we do. And like for another open source effort we do is the datasets library. We host datasets, and these are used for both training regular models and also for transfer learning with transformers. But this is all done in Hugging Face Hub, where it is like a one-stop shop for everything machine learning. And we want to provide people the tools to build machine learning models, share their work with community, and collaborate together, basically. So we do not only have transformers models, but we have basically everything. We have SpaceC models, we have Keras models, we have even scikit-learn models. So you can just train a model and host it over there for anyone else to use. And going back to the point of today's talk, I want to talk about my background a little. So I'm an industrial engineering graduate. I do not have like an IT background. And the most painful thing for me as a machine learning engineer was that, also as a full stack machine learning engineer, was that I had to take my models to production by myself and also do demos to the clients. It's too much work. Like you have to take your model, like make an endpoint to serve it, and make a good UI to that, but this is too cumbersome just to do a demo to your clients, because in the end, what you are preparing is not something that goes to production. Your model is what is going to production, and like you have to focus on what is important, which is your model, and spend less time on building demos whatsoever. So in Hugging Face, we have started something called Spaces last year, which enables you to do exactly that. And, collaboration, deployment, and making demos is like super easy. I'm going to just talk about that. So it is a bit like, some people call it the app store of machine learning. I don't know if it's the right thing to call that, but you can basically host anything on Spaces. You can host machine learning demos made in, like Unity, JavaScript, Gradio, Streamlit. I'm going to talk about how to build demos with Streamlit and Gradio today, and not these, because this is way too complicated. But for instance, this one is a story generator model in French. And this is like 3 lines of code or something that I have written, which is amazing. So, by the way, like if you want to get to internals, basically there was a story generator GPT-2 model in the background, and I have put a from French to English translator in front of it, and from English to French translator in the end to make it French. And this took me like 3 lines of code or something. That's like really easy to do. And I didn't do anything like front end, or like I didn't write any Flask whatsoever. I did it in Gradio. I can also use Streamlit, which is very, very flexible and nice. So how I did it, so I cannot get up and show you because I need to look at the camera still. But basically, I have used something called Gradio. It's a library that lets you build machine learning models with like 3 lines of code. It is specifically built for machine learning compared to Streamlit, if you know Streamlit. So it has something called interface, which you can directly load models into. And as you can see, I have a French translator, a story generator, and a English translator model here. I will get to how-tos of this, but I just wanted to show you how easy this is, like how little lines of code it takes to just make this. Because like this is just the whole thing, the interface is ready to use. You just put the components and your models in the background, and it just works. I'm going to get to how I did this, but like before doing that, I'm gonna just continue. So another thing, like once you have written this application, how you can serve that and make it open to everyone. So you can just create a space and just drag and drop this file to your space, and it works. Basically, it takes like very like a minute or something. You will see I will write my own application. You can just drag and drop, and it will just build, and there you go. It just works. And like my 2 cents in which one you should use is that like Gradio is specifically made for machine learning. So in the background, there's your model, and you just put your input component and output components, and you build an interface with that. Streamlit, on the other hand, is incredibly flexible, but it takes more amount of time because like Gradio has everything out of the box. In Streamlit, you write your components, like it's a bit like more functional, I could say. I'm gonna show you how they compare. So for instance, in Streamlit, you have, Streamlit components, which is like title is one of them. You just write a title to your web app, and then you can put a slider or like a text input or like any other input, and then that component's input goes to whatever your inference function is, and then you can just pass it to your inference function and just output the output of your inference. Meanwhile, for Gradio, it's not like that. So Gradio is a bit more complicated, but once you grasp that, it takes less amount of time to write your machine learning demos. So basically, Gradio interface takes the input component to your machine learning model, output component to your machine learning model. So let's say you have an image captioning model which writes captions to your images. You basically need an image taking component and the text box component as an output component to build your interface. And in the background, you have to write your inference function. It's, let's say, model.predict blah blah, and just pass that function and your input and output components in one line of code, and your interface will be ready. That's why like it's very specific to machine learning. And like a couple of use cases for spaces is that we have so many organizations. I also like at my school, I opened a natural language processing lab, and I am hosting my stuff at spaces. There are so many companies showing their work at spaces, and yeah. I also used to do my portfolio at spaces because like I feel like recruiters do not just go into your GitHub and validate that your models are working or your applications are working. So it's actually nice to show that you are capable of doing this model which suits their use case, so to say. So it's nice to use it as a portfolio, but it's just an opinion, and you can find a more better use case for this. And there are like fun applications in spaces that you might have probably seen. Like there was this very famous space called AnimeGAN that converts your photograph into your anime version. And this is my favorite. You can just, like there was a GPT-J model in which you can have like a conversation with Gandalf and like other cool stuff. And like I normally use this presentation in rather shorter presentation. So I have put 2 additional blogs that I have written, but I'm going to show a couple of hands-on demos today for both Streamlit and Gradio. If you need like a reference, we have a blog at Hugging Face that you can refer to. And also, again, this is usually for my internet speeches where people cannot ask me any questions, but now that we are face-to-face, you can just ask me questions, which is even better. And this is the end of the presentation, and we can go to some hands-on applications for spaces. So I'm going to show a couple. Let's do it like this. So I feel like this is the easiest way of giving an example for Streamlit. I'm going to make the font bigger so you can see. Can you see now? Like, is it good? Even bigger. Okay, sure. Is it better? This is too much. So you will see what I mean with Streamlit is a bit more functional. So basically, in here I have a text data set, and this data set is here. Like, the good thing about Hugging Face is that when you host your models, and if you have the data sets on Hugging Face Hub as well, and like you can actually link them when you mention them in your application. So like this exploratory data analysis is based on this data set of poetries simply. So I wanted to do an exploratory data analysis on the this data set. It has the author, the content, poem name, and age, and this is the application file. And like, I'm going to show you something really nice. All I need is the requirements file for the additional dependencies in here, and my application file, and nothing else. I just don't need anything else to deploy this and let people see it. I also have a README file, but this is needed to, like, this contains the metadata that Spaces needs to build your application, but you do not write it yourself. It's like when I was creating my space, it was already there. Let me show you. When I say new space and I pick my license and the SDK and this, it just creates that README file for me already. So let's go back. So I have imported a couple of tools for my use case, and I'm going to go like this. So Streamlit has a couple of nice components, and they also have like community components, which are, you know, for instance, they have a specific component for Spacey package that visualize the dependencies. They have specific packages for RTC, WebRTC, and other stuff. So it's really nice. You can just get them. But like in here, I only use Streamlit's own components. So I have done a couple of pre-processing for the text inside. I removed punctuations and lowercase things. And then I visualized it using st.data frame that you can see here. It wasn't like necessary for me to, you know, do standardization or anything to do this. So like with only one line, you can write a web application that is going to visualize any data set, which is amazing, I think. And then this subheader is like Streamlit has title, header, subheader, and write to write things. You can think of this like a markdown. And I have visualized the data set statistics and like made a cat plot with Seaborn, and I can just say st.pyplot to print any of my matplotlib, Seaborn, any other plot with this line of code. So you write your plot and then just add this, and it's going to print your visuals. Moving on, I have a couple of other visualizations as well, but like these do not matter. It's just I wanted to show how flexible this is. And I can do word cloud. I can put anything that I usually put in my Google Colab in order to visualize any insight that I have. And this is so nice. This is a Streamlit's own bar chart, and it's quite interactive. Again, you can find these in the API reference of Streamlit. I'm going to do another thing. So moving on, this is one of my favorite applications, and I'm going to show you how I did it. So this was like, this is inspired by Hugging Face's own application called Write with Transformers. So there is a couple of applications of generative models which autocomplete your text. It can be GPT-2 or XLNet or any other Transformers model. And they have, what it does is that basically you write something and it completes the text for you. And in the background, it loads the model and just does the inference. And I can set some parameters with these sidebars that are related to the generative capabilities of the model and how it does decoding and stuff that determines the randomness of the text, let's say. And again, I just need the requirements file and an app file. So these are a bit Hugging Face specific functions, but basically I have loaded the tokenizer and the model. Tokenizer is like preprocessor for a text model, which converts words or subwords into numbers. And st.cache caches this process so your model is loaded faster. And I load the model and I have written the inference function. And it takes a couple of stuff, like again, maximum length, top K, top P, and other things that affects how random the text is. And I write the title, which is here, and write the text. And it has an input component called text area, which you can input your text. And again, I had sidebar over there for these randomness parameters. And I just do inference and I get the output here. And I just print the output with st.write in here. So let me write something. My name is Merve and I am a fellow of, like it just completes randomly. So yeah, like it took me very little number of codes to actually write this. I could have written this with even less number of code, but back then I wanted to use how to use transformers like this. So, and a couple of Gradio examples. So one last thing I'm going to show. So back in the day, I was doing chatbots, and I have written a blog post that is actually interactive because like I wanted to show what models can actually do. So it's good to show what the use case is and how to directly do that. So for instance, I have this blog post, and in here, for instance, I want to show that you can actually use translation models to scale your chatbot to speak a different language. So I have put a Streamlit text area, and in the background, this does inference, so you can see see what the model is capable of right away. And for instance, in here, I have put a question answering model. It has the text and it has the question that is going to be asked to text, and it prints the answer so you can try it for yourself. Yeah, and there is another paraphrasing model that I used to use for data augmentation back then. So like I feel like it can be used for these, like if you want to quickly do something interactive, it can also be used for that. So a couple of like fun use cases. but I'm going to show how to build a Gradio. So this is what Spaces looks like now, and like you can just go and write your use case and also see if a model is there. I want to show you, yes, this one. So good thing is, so if you have the model on Hugging Face, you can just load the model like this and do nothing else. It will just understand how this model is inferred. Just pass the model, and it will understand how the model is inferred. So you don't even have to write the code to infer with the model. So I have written a description to my application. I can pass it to my interface as well. Let me do it like this. So I have written a title for my application. These are like just descriptive stuff. Title for my application, description for my application. I have also written example to guide my users so they know what to enter similar stuff. Like, for instance, I do this example. This example is adventurer is approached by a mysterious stranger in the tavern for a new quest, and it is completed like this. So how is it done? I just call gradio.interface.load, which loads the model into this interface, and I just pass the title, and I pass the input component, which is a text box here. And I also pass, like, because you can also do, like, if you want, you don't even have to write the input component here, because this model takes an input and outputs, it takes a text input and outputs another text, which is known by this interface. So I just did it because I wanted to fit more text here and put a label. So I wanted to customize that, pass the description and pass the examples, and just call interface.launch, and it just launches. Like, there is like 3 files, not even a requirements file, because it doesn't need anything, because the model is hosted on Hugging Face. I could have just written this in like 3 lines of code or something. Like, this is very easy to use. And I have a interface to do story generation with GPT-2. Another cool thing is, I think it was the French one. I wanted to show you the French one as well, because it uses something that is called series, which puts models in series. Let me find this. Yeah. So this is another story generator that is done in French. I have taken the previous model and put translation models in front of it and in the end of it. And this series is a type of interface that puts this, like the input of this, output of this goes into this, and then output of this goes into this. So I put models in sequential manner to do a series of inferences so that I can just make this application in French. Like a pipeline, yeah. Let's see. So the thing is, this application leverages something called Hugging Face Inference API, which loads the models on demand. That's why, like, in the first inference, it's going to take a little bit of time. But like in the other inferences, it just takes less because the model is already loaded and ready to use. Yeah. So this, basically, when you say inference.load, it's going to send a request to the API. That's why it takes less, but like it takes absolutely zero memory because like you are allocated the CPU in the space. So if you load so many models, you can go out of memory easily. And if you, like last thing, normally if you want to build an interface that is, I wonder what went wrong, but yeah. So if you come across any problem, you can build this locally as well for Gradio. If you come across this problem, you can see what's going on in here. But I do not want to open it because it might have some credentials of mine. Anyway, so if you want to directly load a model, another thing is, so if you have a model that is not on Hugging Face, you call, let me go to blog for a second and show you the syntax of this. So Gradio, not this. Today we have released the Gradio 3.0. Wait. So if you want to build a model that is, and build a demo of a model that is outside of Hugging Face, what you do is you write a function to do so. Just a sec, I didn't write it here. You write a function and you pass this into the interface. So instead of directly passing the model, you pass the function. I'm going to just a second find an example of this because I apparently forgot. It's my fault. I'm sorry. So I have a sorting hat application. Yes. I'm going to share my screen again. Not this. Yeah, share this. Yes. So basically, I made the Hogwarts sorting gap application. I don't know if you have watched Harry Potter, but you draw something in here and it classifies you to a Hogwarts house. And oh wait, it's not this one, just a sec. I have a couple of these. Sorting. This should be fine. I'm gonna share all my screen now. So this application, what it does is that it is trained on an image classification model based on Keras, and Gryffindor and so on. So what I did for this is that I'm going to open this in VS Code, just a sec. Download. Okay, I hope my font is big. So I have a Gradio input that is image, type of image. It's called, is it small? Can't you see it? Does anyone know how to get this? Command Shift Plus, okay. I do not have Command Shift Plus, it's Mac. Does anyone know on Mac? There is not a separate thing for, huh? I know. There is not a separate key for plus, basically. It's the same key with for. Command Shift Plus is like, there is a 4 and like on top of it there is a plus. So if you do Command Shift 4, it's going to take a screenshot of the screen. That's how Mac works. Can you get this?
Can you go to View? It's VS
Okay.
Code, right?
Okay, yeah. Okay, it's O. Okay, Shift Command O apparently. No. Okay, it's here. Let's do this.
Yes.
And this should work. Can you see it better? Okay, sorry. So basically, I have an image type of canvas. This is an image input. It has multiple type. Also, there is an image output as well, which you can have matplotlib plots, and we support many things. And you can define the shape so that it is compatible with your image classification model. And your output is a text box that is going to prompt the label. And I have an inference function which returns the output. It has my model prediction. So basically I call model.predict because this is a Keras model. And yeah, it just makes a prediction. And there is a fifth class, which is like a DetEater class. And like if it's detected, then the output is DetEater. Otherwise, it's one of the classes. These are like the 0 or like the numbers are here are just output classes. And what I do, I initialize my interface with this inference function, and I pass my inputs and I pass my outputs. This was the input component and this was the output component, and I pass a couple of stuff like title and description, and I call interface.launch, and it's going to launch an interface. By the way, I loaded the model from Hugging Face, but it's not necessary. Like what this does is that it downloads the model file for you, so it's not that different. You can just call, if you have a Keras model, for instance, you can just call this tf.keras models load model. This is equivalent of doing that on your model path, and just load your model like so. So this is not much different. This is something I have worked on to load a model from a repository, basically. So yeah, I do not have anything else to show. So what it does is that it loads this canvas, and in the background it does the inference and prompts the output, which is like text of the class. So if you have any questions, I can take them, or if we have them in the comments. Nope. If you have any questions about building machine learning demos, you can ask me. But this is like the most beginner-friendly thing, beginner-friendly presentation. So people usually do not have questions. You have question?
Yeah, I have one question.
Uh-huh.
Are you able to use any packages?
What?
Python package.
Yes, you can use anything. So basically, if you want to build an app, like I'm going to create a space demo and I pick my license. I can also pick static spaces, so you can basically write HTML, CSS, whatever you want. And then, for instance, I pick Streamlit. If I have Python packages, I write a requirements.txt file and include them in my application like you would do in any Python environment. I can also add Debian packages as far as I know, like you have a packages.txt and over here you can include anything. Same with requirements.txt. You can add, I don't know, Torch, Matplotlib, and anything else, and just import them. It just builds the environment for you. That's what is so convenient about it. You do not have to do anything.
So it's like Python install a package.
Yeah. Like you can think of it in the background, it probably does pip install XYZ for you. Any questions?
So you show like a lot of inference things. Basically, usually is what you want always to do inference. Is there a way that you can, for instance, if you need to make a training of the models?
Yes, you can also train a model. In fact, like I was working on an interface that does something like an AutoML. So you can do something like this. So you can like I will write sort of like a pseudocode because I do not know exactly what, like I do not know the syntax exactly, but you can just train your model here. This allocates you a CPU. We have like few GPUs we assign to popular stuff mostly. So you can have like, you can make like a drop down of model types, like, I don't know, random forest, XGBoost and whatever, and you can pick one of them and you can drag and drop your training data and you can just train your model. Like you can put like buttons that are going to execute the model.fit and then you can do output inference. Like anything is possible basically. But it's not going to be fast if you are going to do neural network training because it gives you CPUs. I'm currently working on an interface with tabs that has basic scikit-learn models, and it gives you the plot of your model's performance on the test set. So if I release it, I can, I don't know, post it somewhere.
Someone asked if you can share your screen again.
Sorry. I wasn't sharing many things, so you are probably fine. I didn't share anything. Can you see? Yes. So like if you, I just said if you have a file, you can just do packages.txt like any other environments or requirements.txt. That's what I have shared. Any questions?
When you have it ready, you could share it on our Slack.
Yeah, that would be really nice. When I get the thing done, I can just share it. Any other questions? Yes, Adri.
Do you know if you support Owkin and other visualization libraries other than Matplotlib?
Let's check. Okay, let's check Gradio reference because I do not know. So we have an image output. Where is image? No, why do you want to use my camera? So I'm gonna give this as a feedback. So there is, for input, you have webcam, sketchpad, and pillow component. But I am looking for output. Okay, so we support Plotly and Matplotlib, but if we are supporting Matplotlib, we are also supporting Seaborn, I would assume. I do not know if Bokeh uses Matplotlib. Okay, I did not know that. So I always use Matplotlib or Seaborn. So it probably supports that as well. This recently came, and I'm just loving this. There is other stuff. There is even chatbot component, 3D components. Yeah, like we have recently introduced data frame, which I am experimenting on. This makes everything so easy because you can just drag and drop a data frame here, and it just prompts it prints the header for you, head of the data frame for you, and you can, in the background, you can train a model or do an inference and then just print your predictions. It's just like, if only I knew about this stuff when I was trying to do like a demo to my colleagues, my life would have been easier because notebooks are boring and messy. Yeah. Any other questions? Yeah.
Thanks for your presentation. So in the code you showed,
Sorry, I stopped sharing this. Let me share again. Yeah, please.
this in English was only another like snippet of code which was using the interface from Gradio.
Can you be a little louder?
Excuse me. Like in the code you showed,
Uh-huh.
you were using an interface to load model from plugin face.
Yeah.
Was plugin face / plugins.
Uh-huh.
Implicitly, it means that you're using plugin face, but can you use any other vendors or other providers?
No. So basically, before Gradio was bought by Hugging Face, Gradio has developed a integration to do this. So reason why they are doing this is the pipeline function, which is, I think, the best thing in Hugging Face. Let me show you. I do not know if other model vendors have this, but this is like an abstraction over models that, for instance, usually image classification models take an image and prompt a class label, right? So this inside has everything. It's like a box that has the preprocessors of your image, which is like taking a pillow image and doing something, and the model, and it outputs the, how can I say, outputs the label. So it's like a box which you can just pass your image and get the output. And this pipeline is used for inference API. So to inference API, you send a request and like it does the inference and gets the output to you. You can also use this pipeline, just download the pipeline and just use it. That's why Gradio is integrated, because Gradio works in the same philosophy of input and output. I think that's why, because we are like friendly to other vendors as well, like DeepSet and other things. It's just the philosophy is the same. I think that's why it was integrated and easy to use. Question answering, it takes a question and the text the question is asked to and prompts the answer. It takes two text components, one, and it outputs one text component. And that Gradio interface knows that, because those models, question answering models, are labeled as question answering, which says, hey, this model takes 2 texts and outputs 1 text. So hence, so these are like, with 1 line of code, you can download that model from the Hugging Face Hub and start doing inference. That's why these are so convenient. Any other questions? I really don't want to take more time because we have another presentation and I want to be respectful of their time as well. You can maybe ask me later. Do you have a question?
How the front end, how interactive can we make the front ends? Like, can we like use it for example, if it was hypothetically a log streaming of results from an ML model, can we show that in a dynamically changing?
Yeah, you can build any dashboard or whatsoever. I'm currently working on that for Gradio at least. I love dashboards and like you can already do that for Streamlit, and I am doing that for Gradio as well for, you know, with the plotting components and data frame.
Can you embed an app like that somewhere else?
Yes. So from us, when you put a space, you can embed that space, if it's Gradio, not Streamlit, to your blog or wherever you want. It is done in the documentation already, but like people have been doing this in their blog posts in WordPress, for instance, to embed a demo. You have a question? I thought you have a question. Okay.
Can we like use Gradio for like a standalone application also, independent of spaces?
Yeah, of course. So many people do that. So like in the function in the background, you can just say print hello world and it will just print hello world. You don't need to use it for machine learning only. Okay, if you don't have any questions, you can ask me later as well. I do not want to take any more time. Thank you so much for listening. I'm gonna get out of the StreamYard.
Can I like reorient the laptop this way? And I can try to. Hey, hi. So first of all, I want to thank the Pyladies group for inviting me and dataiku for hosting this event. It's super hard to go after such an incredible presentation with so many cool Python demos. I must warn you that the content of this presentation is going to be less technical than the previous one, but I will try to communicate my enthusiasm for what I am doing at Owkin. So I'm Jean du Terrail. I'm a senior research scientist at Owkin, and I will start my presentation by maybe introducing a bit what is Owkin doing. Then I will go on to talk a bit about data, because machine learning is always about data first. And then I'll introduce what is this federated learning thing that people are mentioning a lot recently. And then I will talk about, I think, like the most interesting bits of the presentation will be about the actual use cases that Owkin has encountered, doing real-world federated learning, and I will try to explain, how, this is a step further, right, than doing simulation and demos. And I will finish my talk by, talking about like the challenges, the research directions that we are exploring currently at Owkin. And I will also mention that we are hiring a lot since, we are scaling up, and I will have a slide on this. So first of all, what is Owkin? So first, to understand Owkin, really, you have to understand what is precision medicine. So really, when I started working at Owkin as a layman, I had this vision about medicine that it was, something really theoretical. You have this medicine classes in France. You have to go through, 10 years to become a doctor, but it's actually very empirical, right? Medicine, really, you give a treatment to a patient and you don't know basically what's going to happen, right? I mean, even in 2022, we're still, at this point, and we need to, go beyond this. And so this is what the promises of precision medicine is. Is there something that we can identify about a patient that will tell us, is this patient going to be, going to answer well to this type of drug that you're giving her or him, right? And it's, you can have like the same disease exactly, and you can react very differently, right, to a certain kind of drug. And so we're trying to use the data and machine learning and federated learning to answer this question, which is a pretty hard one. And so really, in order to really answer this question, we have to gather some data, right? And some data from a lot of different data modalities, right? And what is really critical about healthcare, right, is data is siloed, right? It's behind firewalls in hospitals, in France, all over the world. And really, it's hard to get this access to the data. And federated learning is one of the options to, unlock the true power of the data, especially for diseases that are very rare, right? Because if you don't have enough data, you all know that your machine learning models that are very data hungry will not work as well. And so we're trying to find what are the characteristics of subgroups of patients, subtypes that say if you're a patient, you're a woman and you have red hair, you're gonna react to a specific kind of drug in a very specific kind of way. And we're trying to find what are the characteristics that are important, and those characteristics are hidden inside the data, and you really have to use and harness the power of deep learning to really make this insights come out of the data. And there is also, and I'm really glad to have that you had this talk by Merve, to have this deployment part, because once you have a model that you think it's good, then you have to put it in clinical practice, right? You have to put it, and you have your grandmother and your dad, you want to be able to use this model on them as well. And so I think it was like the first speaker who talked about uncertainties of the model. So it's really important to be able to quantify the distribution shifts, the uncertainties, and all of that. So Owkin, to unlock the power of machine learning to help precision medicine, we have a network of partners that we're trying to grow. And in France and in Europe, it's already quite a big network, I must say, and we are trying to expand further, right? Because you don't want to be limited to France, because some insights, maybe in the US population, it's more easy to get some insights about some cancer or some disease. And so really, I will start by, of course, you all know this, but it's always good to have some reminder about, why, where does machine learning come from, right? So the first step that you all learn at school, or while you start, doing data science project, is to really assemble something large and something that is well curated as well. So data curation, of the data set is something that is most of the time hidden, but that is, one of the essence of the problem, because, you have all these big models, from OpenAI, like the DALL-E 2, that, just, scroll the web and, they find a big model, but it's only, for cool applications. If you want to find true insights in the data, you have to curate it. And, there was a lot of initiative, with the ImageNet, with the MS COCO, NIH chest X-rays, to enable the progress of machine learning. So the second thing, of course, is deep learning, the advent of, these big models with a lot of layers, activation, batch normalization, also those kind of things. You had the hardware also, that really jump-started this revolution of data, with Alex Krzyzewski, competition on winning like the first ImageNet challenge. And something that you don't hear quite a lot in the presentation, and that I want really, because it's Pyladies, to really focus on. And it wouldn't have been possible to have a revolution at scale without, an open source data science ecosystem. And I think, a lot of libraries, and Python plays a major role, in, making science, spread out, right? And, getting, now, you don't have to have a PhD in machine learning to learn a model, thanks to Hugging Face and PyTorch and scikit-learn and TensorFlow, from, Keras from pre-trained models import VGG, right? And then you're on. And, it couldn't have been possible if there wasn't, this, impulse at the start to really have this. And also the paradigm that you're all familiar with is I have this data center, right? It's all pooled, and then I launch my models on top of it. And, you can scale it up. You can have like a full data center, or you can have one laptop. You can buy a GPU for yourself. It's still a bit pricey, but, it's doable. But you have this paradigm of pooling the data, and the data is at only one place. But really, sharing data is not that obvious, right? I mean, you have data regulations that are coming. So in Europe, you all are all familiar with the GDPR. In the US, so is the HIPAA, and there are regulations everywhere in the world. And you can't, use data and from users and just put it in an open source fashion. It's not always easy. And when it concerns your health, the fact that you have a cancer, you don't want to be aligned in a data set in the Hugging Face hub, right? And there is also a lot of public sensitivity about, all these issues about personal data. I think I remember, 10 years ago, you didn't care, you went to the internet and you didn't have, to opt out and to accept the cookies of every website you actually went to. And now, because, it has become a critical issue, because you're aware that, your data, is gold, because it's what allows the progress in machine learning. And, you don't want to have this breach of data that's happened. And also, when I started Owkin as well, I had maybe a bit of a naive idea of, what is, the academic work. I was like, the academics, they work, to move the research forward. But there is a lot of competition in between labs, right? I mean, if you're a researcher at Facebook, you don't want to share your data with a researcher from Hugging Face or dataiku. And, data sharing obstacles are really there, and you have to find a way to kind of, go around them, right? And also, two factors that we don't talk often about as well is data obsolescence. So when you mention federated learning, like the first example that is given is one of Google use cases. It's a Gboard word prediction, and since we've seen all this superb Hugging Face demonstration, you can see that with a model like GPT-2, you can infer, you can start typing, and then it will predict the next word, right? But language naturally evolves, right? I mean, you have seen the slang that you were using in high school. It changes. So you have like "kofefe," that is becoming a word, and all these changes of languages. You have to keep data fresh, right? Because things change, right? There are distribution shifts. I think at dataiku they do a lot of active learning too, because you want to adapt to what's coming. And in the medical world, you have new treatments, every couple of months that are introduced, and since we are exposed as patients to a lot of different, inputs. Now we are surrounded by, cell phones, pollution, and a lot of external factors that are changing. What is the impact that they're going to have on my health and on my machine learning models as well? And then you have also the data transfer costs. If you want to keep data fresh, you have to constantly, upload your data. And you have seen, the first time you upload some data, you have seen on the Hugging Face demo that it can take, quite some time. And, when you talk about, the massive amount of data that is used, in GAFAs, you have to constantly, feed a big data center, and, it cannot scale, right? And you have to, be very, the speed of the data exchange and the transfer has to be like tremendous. Like the most example of this is like self-driving cars. And when you have a video feed, when you have video feed from 10 cameras, when you have lidar, radars, can you imagine like the amount of data and the amount of transfer that should occur if you had only one place where you pulled all the data? I think I have successfully convinced you, or I hoped that it's becoming a limit, right? I mean, we can't go over that. So one of the solutions is federated learning. And so what is this federated learning? So first, a little recap about when we have the data all in one place. So we have volume, we have critical data, critical mass of data, so we can train powerful machine learning models. We have flexibility, where if all the data is at the same place, with the Hugging Face and PyTorch and TF, it's super simple, right? If you have the compute power as well. But, it's hard to refresh. There is a GDPR. There is, a lot of regulations that are going to be a pain in your ass and that are going to, hinder you and prevent you, from pulling all the data into this one place, right? And data is also a strategic asset, since, it's the new oil. I think I saw that in an article written somewhere. And so it costs money, right? And so you cannot pull the data in all of the situations. So federated learning, it's the ability to train a machine learning model on multiple data centers. So the advantages that it brings are numerous. First of all, it keeps the advantages from the pooled data. So you have volume, you have flexibility as well. I mean, it depends exactly on how you interact with this federated network, but I will talk about that afterwards. And data can be refreshed all the time because, since you're working on multiple data centers, you can get close to the data, right? Close to the fresh updates of data that you're going to use to feed those data-hungry deep learning machine learning models. And so, it's also a big line of work, to ensure compliance with all those regulations. But with federated learning, you can see, it's the first step, to get like the stamp to allow, this kind of research, right? Because data stays in the center, so the data privacy is ensured somehow. And centers, keep control on the data, so they can know exactly what is the data that you're, working on. A bit like a Kaggle competition, when you have a separate test set that you can't access it. So the medical partners, they have this ability as well. So what is federated learning doing in practice? So I had an animation, but it's not working, of course. So I just have to wave my hands around to make the animation move. So first of all, the first step, so it's an iterative process that is very simple, that everyone can understand. So first, there is a local training that happens, on the data centers. So back behind, the firewalls of a French hospital, for instance, you have some local training step. And then, so it occurs simultaneously on all the centers. And then you have this averaging of model that happens on the central server that is trusted. And this central server, it dispatches, the results of the aggregation to all the centers back. And it's this back and forth, between what we call the clients and the server. So the clients train locally their machine learning models. They send it to the server averages them, and it gives them back. And so they have this global model that is infused with the data from multiple sources. And so you gained exactly what you had when all the data was pooled, right? You used the knowledge from all the sites that were in your federated network, but the data, did not move from the center, only the models did, right? So when I say models, I mean either a model or a gradient, or some proxy that is very indirectly tied to the data. So of course it brings the performance. So it's almost equivalent to what a pooled setting would give you. It enhances the privacy and the data member of this federated learning network have ownership over their data, and that is really important. And so as a recap, and so there is this quote from our DPO, which is the people that is whose responsibility is to make sure that everything that you do is compliant with the regulations. And he says that federated learning is key to kind of keep the privacy and put the patients first, and to try to get the same amount of insights from the data as you would have if you had this pooled setting that we would like to have, but that we can't necessarily have all the time. And so we break data silos, we preserve the privacy of the patient, we maintain the governance, and we build trust. And I'm going to go back on the trust and on the privacy part when I would get a bit more technical into the presentation. So federated learning, it's a big word. It can be a word to talk about, the machine learning process, but there are a lot of bricks that you have to put in order to have something that is very private, right? Because the only thing, maybe, when you heard my presentation of FL and exactly what is it, maybe you were startled by the fact that, we're still exchanging models, right? And, since the models have been trained on a local data, they might have some information about the patients themselves, right? You could, devise some attack to kind of, do retro engineering on the gradients and to come back at the patient's data. But you have a lot of things, that will be able to prevent those kind of attacks on the data. So one thing that is very easy to actually do is to use cryptographic protocols. And it's very good because they are theoretically proven to, be bulletproof. Before, we have quantum computers, to defeat all the protocols that are in place. But, if we have to wait for the quantum computers to be there, we won't have credit card or email. So, we're safe on this thing. And what is this secure multi-party computation thing is to use the power of integers. All the machine learning models that you're used to are using floats, right? Or this 32 bits precision, and you convert them to integers. And through the power of mathematics, very deep mathematics about groups and all those kind of things that you learn in in university or prep school, and it can guarantee you that the data will be hidden and that won't be able to be recovered, right? You have one thing called trusted execution environments. So this level of privacy is even deeper. It's at the level of the hardware, how can you make sure that every operation that is going to be run is exactly what you expect? And you have this traceability, using technology based on blockchains. You have this unfalsifiability, and every exchange, between one client and the server is logged into this blockchain network, so you can't cheat. And there is this additional brick called differential privacy, which is a very theoretical brick as well, which is basically you add some noise on the models that you're going to exchange, and it will protect you, and it will give you very, very strong guarantees that we won't be able to learn anything about a single individual patient, because basically the distribution of the gradients that you would obtain from the dataset that is local would be exactly the same and undistinguishable from the same distribution if you were to remove one patient. So you have all these bricks, so it makes the thing kind of complex, right? Because you have this optimization and all these privacy layers, but this is what is true federated learning. So we have this technology stack. So since we are at Pyladies, I'm gonna just dig a bit deeper into this federated learning stack, with all these bricks that I mentioned. And so you can imagine, that there is, the software is deployed behind the hospital's firewall in different hospitals. And there is this backend, there is this server that is in the center, where all the models will go through. And there is this traceability. And the data scientists, that work in Python will be able to just code their model and send them on the federated learning network and have, this iterative process that is going on with all the guarantees of the privacy that I mentioned. And then what we do at Owkin is we go a step further. So we have a platform as well, a bit like Hugging Face, where with sliders and a lot of things that are, less nerdy, I would say, that are for doctors to really understand what's going on behind, you have these deep learning models that are black boxes, and you want the doctors to be able to trust them. So you have to open the black box and really go into deeper into the interpretation part of the models. So this federated learning stack, it's a lot of things. So it's, there is the machine learning statistics and algorithm part of it. There is the monitoring part. You have the federated learning schemes, right? Because this aggregation and this iterative step, it can be done in several kind of fashion. And some fashion are appropriate for certain use cases, some fashion are not. And so you need to have this, permissiveness, and to be able to have exactly in Hugging Face, you want to be able to type, 3 lines of code with your Keras model or PyTorch model. And then you want it to be able to, be dispatched to, some clients, some hospitals, be trained, and, maybe the model afterwards, if it's validated by the centers, it gets back to you, right? And you can use it. And, there is this backend, based on the blockchain technology that is Substrate, that is open source, and that I am encouraging you to actually check out. You have this unfalsifiability of the exchange. So you can't lie to a partner and say, I trained this algorithm, but I actually, used the test data, or, I didn't train it, I memorized all the labels. No, you will be able to see exactly what algorithm has been run on which client. And, there is the backend part, which is in Docker and Kubernetes, and it can be deployed, I would guess, exactly as Hugging Face models on AWS, GCP, Azure, or on-premise, if for some use cases you really need this extra layer of ownership. And so really, so you have something that is on the partner side, right? And it's important to see this as 2 distinct blocks. You have the data scientist block, on your laptop, and you have the partner side. And you will never go to the partner side. The partner side is where is the health data is. So you don't want access to actually this. You have to go through this federated learning secure network to actually train your model. So we have a CLI and we have libraries, as well, where you can use, PyTorch and all this, fancy new tool, and that is installed on your machine, and you will be able to launch computations that are going to happen in a distant server. And it's not that trivial, right? Because, when you iterate on a notebook, there is always mistake, right? And, when you code, you make mistake all the time. I make mistake all the time. We all do. And if you do a mistake, you send your code on a distant machine. How can you be able to access the logs, right? How long is this task going to take on this specific node? All of those questions, are answered by this solution that we call Owkin Connect. And that is our federated learning stack. So the workflow is, first of all, the partners, the data owners are going to register their data. So they're going to be, the owner of their data and decide exactly which of my data is going to be accessible to this federated learning network. So you can have permissions. And they will also say how exactly is my data is going to be loaded into the Python runtime. And this is very important because it prevents cheating as well, right? Because you would be able to sidestep the thing and load the ground truth as well, or do some clever hacks. But everything happens inside Docker containers. Everything is permissioned, and exactly how the data is loaded is controlled by the partners. And then you have this registration of your algorithm from your Python libraries, and then you have your model back, and you iterate on this data science process. But now I'm going to get into the crux of this presentation, which is, what happens in the real world, because in the literature, often you can find a lot of proof of concepts. And, I'm a researcher. I love proof of concept, because it can allow you to get the hang of exactly, what's going to happen in the real life. But when you're tackling federated learning is very simple to simulate, right? You have all the clients on your runtime, on your Python runtime, and you simulate, right? You say, hey, this is a hospital, but it's only an object in Python. But to go from, this simulation from the actual deployment is quite hectic. And this is what we've been able to do at Owkin in multiple cases. I will present only two of them. So first, and they're going to be answering, these precision medicine questions that I talked to you about in the first slide. And so first of all, at Owkin, we talk with the doctors and we come up with a medical question that is worth to be answered. Because, in machine learning, so it's always funny, the ImageNet is the standard, right? And ImageNet is this classification task where you're trying to differentiate between different races of dogs. I mean, it's nice to do that, but, what's the point, right? And so we're trying to, move science forward at Owkin. So we're trying to answer questions where there is no answer yet. So there is a special kind of breast cancer that is called triple negative breast cancer. That is a very aggressive cancer with a very bad prognostic. And you have this response. So basically what you do is you give the same treatment to all the patients, and some patients are going to respond well, and some patients are not going to respond well to the chemotherapy that is given, right? And to this day, really, it's very hard. And you're kind of, it's mandatory to give the same treatment to all the patients, but a lot of the patients are not going to answer to this treatment. And when you deal with a cancer, you have to, be very, very fast, right? Because, the patient's chances, they decrease with the amount of time that it takes to, get the first treatment. And so you want to be able to, have from a slide, so from this big carrot of flesh that is extracted when you have a cancer, and, it's sliced, and it's imaged onto a scanner. And from this slide, you want to be able to predict if this patient is going to answer well to this specific treatment. And we worked with two partners centers, which is Institut Curie and Centre Léon Bérard. I think if you live in Paris, you probably know about Institut Curie. Centre Léon Bérard is in Lyon. So you probably know it as well if you went to Lyon. And we're trying to answer this big open medical question. And what we showed in this HealthChain project, which was financed by the BPI, the French Public Bank of Investment, and which involved a lot of public and private partners. Basically, this plot is how well is the model performing, and why is there two sets of box plots? Because you have multiple centers, right? You have two centers, and so you have the plots, in red. In different shades of red, which represent, the clinical standards, what was, used to be done, by the medical doctors to actually do the prediction. In different shades of gray, you have the local models. And you can see with this federated learning stack, you can learn a model in Institut Curie and transfer it to get the performance at Centre Léon Bérard and do the same in the other way around. And you can see that the transfer performance is quite good. And when you see that, you're like, yes, federated learning is going to work, right? If the model is transfer, that means data is complementary. The harmonization step is done right. And the models in blue prove that, you can get even better than the local models. And so when you add all those small improvements with federated learning, you are able to reach a critical mass of data on this very rare kind of cancer, because triple negative breast cancer is very rare. It's only like 10 to 15% of the breast cancer each year. And with federated learning, you kind of, so you have all these steps to really put this federated learning network into place. And I will go on some details on exactly what are the steps. But with this and with this platform, you can make sure that everything is done right, because you have traceability and you have audits of the code. And your models are, getting this insight that was hidden from the siloed data. If you were to only, look at Centre Léon Bérard or at Institut Curie, you wouldn't have the complete picture. And there is this metaphor that I like to draw between, when you look at a statue from very far away, right? You have a certain angle on the statue, and so it can, give you a lot of things about the statue, but you will only get the complete picture, right, if you get, some other point of view on the statue, right? And for this medical open question, you really need to really understand what's going on, right? You can't just have a model that is good. You need to understand, what is the physical process that is at play that will influence the response of the patient. I will talk to you and maybe close my presentation on this. Another very big project that we are doing with 10 big pharma. So I'm not going to list all the names, they're listed here. So Amgen, Merck, Novartis, GSK, AstraZeneca. And Melody is a very different kind of problems, a bit akin to what was showed in Hugging Face. So the input is sequence, but it's sequence of molecules. It's a representation called a SMILE that you can, a first order approximation is really a sequence of words, because molecule can be seen as a sequence of words, just other kind of words that you would have in text. And then you want to predict if for a specific molecule, it will have a good effect on a target. It will inhibit the target. And this is a process that is super costly, and that takes a lot, really many years to actually do, because, we don't know. As I told you, medicine is very empirical, and you basically test millions of this molecule formula, and you will have to do some, a chemistry test, and, assemble the molecule, wait for the test to have some results, and then you will be able to say, hey, okay, this molecule, it's working well, it's inhibiting the target. And what I can tell you is, even this process that is super hard and that big pharmas are putting a lot of money into it, it's only the first step of the process. Because the second step, once the molecule is working, is to test the toxicity of the molecule on a human. So first, on mice, then on a human, and then there is, these clinical trials phases, and it takes a lot of years and a lot of times. And we want to be able to quicken this process to get the drugs to the patients in a faster pace. And so this project just finished a couple of days ago. I think it was last week that it was announced. And in this process, you have this secure aggregation layer that I mentioned you. This layer based on cryptography that prevents, the pharma companies from, getting a peek at the data from a competitor, because we're totally in this setting where the competition is really hard, right? If Merck has access to the data of Janssen, there is a big issue, right? And so this brick has been put in place to secure the training of the machine learning models. And the results in terms of relative improvements per client are really working. So it was a 3 years project, and that we showed that even if the data sets were blind to them, all this visualization that Merve mentioned you can forget that, right? The visualization, you don't have access to this kind of visualization. You're blind because you're doing federated learning. And even if this blind kind of setting, we managed to have an improvement for almost each of the partner. And of course, it tackles data imbalance issue. What happens if a partner, has a big data set and one partner has a very small one? Can we quantify the effect of exactly the data set of each partner? Very important questions. So 2 consortiums are coming and really pay attention, to the media to have some updates about them. You have the big picture, so big consortium sponsored by the IMI, 72 million, 45 partners. A lot of federated learning is going to happen very, very soon. And you have this Optima as well consortium with 21 million and 36 partners. Initiatives like that are starting to appear, right? It was very, very hard to jumpstart the movement, but now it's on, right? So the game is on, and we can together make progress in medicine. And I will finally finish my talk and have hopefully some time for some questions by talking about the challenges and the research directions that we are trying to study at Owkin in this research group. So first of all, one challenge that we don't study in the Federated Learning group is the legal challenges. It's very, very, very big, the steps that you have to make in order to, talk about federated learning to partners, that don't know anything about machine learning. So here with this audience for Pyladies, I'm, talking to experts of machine learning models. So you can all understand what I said. But really, when we talk to a new partner, they only heard the name and they want to be really sure, what's going to happen with my data. And since, the models are going to be exchanged between the centers, you have to sign contracts between centers, right? And so to sign a contract between Janssen, Merck, AstraZeneca, and all these pharmaceutical companies, it takes time, right? And, because it takes time, it's not like Gradio where you can have a cool demo, in a snap of a finger. It takes time. And really, you have to have like super good legal team to really move things forward. And really, there is a lot of work to, explain, what's going on under the hood. There is the IP, right, of the model. So, you all train a single model, and then you're like, okay, we're going to sell the model for 10 billions. How do we split, the revenues that we get from the model? Big question, right? Is it proportional to the dataset size? Maybe. I don't know if you've heard about Shapley values, but one dataset size, even if it's very small, maybe it has the insights and the amount of data that will be able to really reveal the insights that was hidden before. So the dataset size is a good proxy in a first order approximation, but it will not go that far. You have to manage the partners, in this network of partners, this IT network. You have to manage their expectations. You have to work with their IT team, to set up all the process. You have to build trust. Trust is really like the most important part, I guess, of federated learning, because it's all about, this federated learning technology that is Owkin Connect is all about building trust, right? And there is also an aspect of the project that I talked a bit on during the first slide is standardization of the data. There is this curation part of the data set. You can imagine that when you're dealing with data that is from a French hospital, not all the French hospitals have the same exact data, right? Data, it can be as simple as, having another name for a category of variable, it can be called blood in one center and sang in another center, You can use, language models, but it can be also the ranges of the data, maybe the population as well. And when you add all those unstructured types of data like pathology images, the scanners that are used in each hospital are introducing, some subtle differences between the distribution. The format of the slides, it's super hard. When you're dealing with CT scans as well with all type of image data, it can be as simple as PNG, or TIFF or JPEG. and it can be very, very far. And of course, you have the intersection of the variables. In one center, they measure, they're really thorough in their medical examination. They measure blood pressure, your level of the beating of your heart, the color of your eyes, a lot of things. And in the other center, they just measure your age and your height, right? And so you have to work, with different types of data, and you can't just say, hey, I will concentrate only on the intersection of the variables that is there in all the centers. Because imagine you have 100 centers and the intersection is just one variable. You will not go very far. So, you have all those type of questions that are very important. And I will finish by this. Distributed ML, heterogeneity, the privacy is always super hard to get right. And you have this federated data science cycle, that is a bit hard as well. When you train a machine learning model, you want to validate it. When you train it across multiple centers, it's kind of hard. It complicates the iteration that you do on a notebook in the usual fashion. And I will just mention before the questions my conclusion. So we are hiring a lot. And at Owkin, it's really important for us, the diversity. And really, it's important, to have women, in tech. So currently, our hires rate is 60% male, 40%, women. And we're trying really, really hard to get that up, to hire more women. And so really, if you're interested about this presentation, if you want to help, moving medicine forward, if you want to do federated learning, to work in really complicated tech stack, really, we have a lot of opportunities. I just spotlight 3 of them, but I checked on the website this afternoon, there were at least 20 of them. So, please go on the Owkin website, and that's it. Thank you very much for your attention. Do you have any question? Yes, Merve.
I have a couple of questions. They might be very simple. So, firstly, putting aside all of the encryption and everything, do you, for instance, assume that you are training a neural network, you simply serialize your optimizer and weights and just keep training? Does it apply for federated learning as well?
Yes, I mean, there is some serialization step that is involved, because at some point you have your PyTorch model or your keras model, and you want to send it right to a distant machine. So of course you will have to go through this intermediate kind of format, but you have to serialize a lot of things, right? You have to serialize the code, you have to serialize the model, you have to serialize the weights, you have to serialize the architecture. And all those components, we're using standard Python building blocks. I don't know if you've heard about Cloud Pickle. It's.
I mean, for keras, it's mostly the same model format, which also has the optimizers and everything. Pickle is a bit malicious sort of.
So yes, so it can execute arbitrary code. Yes. So of course, we have this trusted. So there is a lot of safe guides that are put into our software to avoid these kind of things, right? But we need to serialize other things than a keras model, because we want to allow for flexibility, right? We want to be able to train an XGBoost model as well, right? And you have all these kind of things.
My second question is, I saw that you are using XGBoost and cards. How do you do continuous training? I know that scikit-learn has a Python API, but as far as I know, you cannot do continuous training. You have to train from scratch from the data pool that you have mentioned.
So since we are working in this, blockchain-based federated learning, everything is stored in the ledger, right? So every checkpoint of your model, if you have the right permission, if the partners give you access to the model, you will be able to use it as a checkpoint and continue learning your model. So of course, there is a price to pay in terms of space, right? So at some point, you might need to delete some models, but the partners have to authorize that as well. But the metadata that will be tied to the model will be forever and ever in the blockchain.
My last question, I have a question about that.
think I forgot about this.
Okay, maybe let's take another question. Yeah.
You said you store everything on the ledger. Which one?
So there is. So we are. Our technology is based on an open source technology called Hyperledger Fabric, and you can take a look at all the technical details in Substra. That is open sourced. Really, I'm not. I'm more on the algorithmic research side, so I won't be able to dive deeper into exactly how this is done. So it's not a blockchain per se. If you talk to an expert, it's a distributed private ledger. Yes.
Are you using a standard for metadata? Like, for example, are you using model cards or similar?
Model what? Sorry.
Model cards.
Oh, so in terms of specifications of the models, we're not. It depends really on the partners. So we want to keep something very custom, right? Because it's not the same setup when you interact with hospitals and when you interact with pharma partners. And so a lot of those specifications of machine learning models have been created and are being created at the time as we talk. So we are doing some research on exactly what is a model card, what is the information that you put inside the model card to really define a model. But really, it's ongoing research, and we want to adapt, to the new standards, because we all know first it was TensorFlow, now it's PyTorch. It's everything changes at a frightening pace in machine learning. Maybe another one, maybe. Yeah.
So how does the data coding process work? So imagine you're training your model, and you train it there, you realize there's some issue. Can you actually connect to the remote node and see the data, or no?
No.
Okay.
So it depends on the setup. For a big project like Melody, you can't. You don't even have access to the logs, right? But you can ask partners to say, hey, something failed. Can you take a look at the logs? But we want to have something that is bulletproof when we know that it's not going to fail, right? We know it might fail because of performance, right? Because our model is just not working. But it will not fail, using our technology. It will not fail because of value error, index error, all those kind of things.
Thanks for your presentation. So you talk about declarative privacy. Can you talk about the algorithms or frameworks that you use? For example, are you using frameworks or specification like OpenMind?
So we are not using OpenMind. So there is a cool PyTorch library that is open source that is called Abacus. So we are not using that internally. We have developed our own bricks because we thought it was faster back then. I think it has changed a lot. It might be worth investigating. We did a PR on Abacus because the batch sampling was not correct. So we are trying to really, and differential privacy, kind of a hard topic where standardized things are changing quite quickly as well, which is a recurring topic. We want to be on top of that. Sorry.
So are your models online? They update their results dynamically as more data flows in, or is it processed in batches?
So it's processed in batches, so it's not streaming. Since we're doing limited, project limited in time projects for the moment, but it could be used for other kind of applications.
So is Melody like an in situ drug discovery system?
Yes, exactly. To try to find if a molecule is going to inhibit targets. So basically, if a drug is going to have some effect or not.
3D conformational data of the molecule and its interaction?
No, so we use a sequence of words, so it's called SMILES. It's just like a sequence. Okay. It's not like AlphaFold, but we have other projects. Yeah.
Do you handle pre-processing because you have specificities of data?
So how the data is uploaded into the runtime is done by the partners. But there is this big harmonization process before, and we're trying to come up with something that is automatic and end-to-end. But I must confess we are not there yet, right? There is still a bit of a manual process and handcrafted process that is involved to those data to the Federated Learning setup.
So you do have to share
data at some point, just to make sure you have the same?
No, so one trick that we often use is share fake data, right? You generate random data with the same ranges and the same levels. And so you use that, as a, but we have multiple bricks. I don't want to go too much into the details. Maybe one, I'm over the time completely. Okay, so maybe one last question. Someone new, maybe? No? Or Merve, please.
So in Federated Learning, do you tackle the time series model setup? So my question is, how do you handle data drift if that's the case, or seasonality?
So there is two questions. So Federated Learning is just a paradigm to train more on multiple centers, and when you don't have access to the data. Then there is how to handle time series. Really, time series is not something that we study a lot at Owkin. So we had some studies back in the days about longitudinal studies. When you have a patient that goes into the same hospital and he has several samples that are taken at different amount of times, and it can get you some information, and you have a certain kind of time series that you can get how the disease is progressing. But in terms of time series, as I guess you imagine, there is a Prophet library by Facebook. You have the ARIMA package by Rob Hinman in OR. But it's not the type of data that we are dealing a lot at Owkin yet.
You have a big data pool and you are adding on top of everything. Is it hard to do the data drift?
So we have, and I will use that to close this. We have an answer that we took from the medical doctors is how to validate your model is not going to be impacted by distribution shifts. We just test on multiple new centers in a blind fashion, right? And currently, really, so it's a long process, because we have to integrate, this new center into this Federated Learning loop. And we have to make sure that it's blind, and this is what they call in medicine external validation. And all that's the models that we sell at Owkin or that we use are going to be validated on this external validation in very tough conditions in blind settings. And then when they integrate the clinical practice, they're going to be tested live, right? And so there is a calibration phase to accumulate for the drift. And then, in clinical practice, you have a constant feedback to really make sure that the model is doing exactly what you want it to be. Thank you very much.
Okay, so thanks a lot to the speakers again. And if you have any more questions, there is a networking session now. So the food is just in the kitchen. You can go and ask the questions and meet you and so on. We will probably be organizing more relaxed event in June, probably just meeting in the park. So stay tuned for that if you want to join us for an event before summer. Okay, thanks a lot for coming.